Hello students, welcome to Educate. Today we are going to see some numericals based on projectile motion. So we have studied that horizontal range R is given as u square sine 2 theta divided by g. Maximum height is u square sine square theta divided by 2g. Time of flight 2u sine theta divided by g. And also we have studied that for two angles of projection, the horizontal range is same whether angle is theta or 90 minus theta. So on the basis of these concepts, we are going to solve some numericals. So here question is, a bullet fired at an angle of 30 degree with the horizontal hits ground 3 kilometer away. So here horizontal range is given, theta is given, theta is 30 degree and horizontal range is 3 kilometer. By adjusting the angle of projection, can we hope to hit a target 5 kilometer away, assuming the muzzle speed of to be fixed and neglect the air resistance. So here question says that if situations means only we have to make adjustment of the angle and we want that horizontal range should reach to 5 kilometer, whether this is possible or not. But there is one condition, velocity will remain same, means speed is not going to be changed. So let's see whether it is possible or not. So we know that R equal to u square sine 2 theta divided by g. Here 30 degree is the angle and the ground 3 kilometer away, R is given. So you can write 3000 equal to u square sine 2 theta. So twice of 30 will give sine 60 divided by g. You can take g as 10. Sine 60 is root 3 by 2. So 3000 equal to u square into, this will become 3 by 4 because root 3 by 2 get, sorry, here just sine 60 root 3 by 2. I'm rewriting because it will create little confusion. So here 3000 is equal to u square sine 2 theta sine 60 degree divided by g, where g is 10. So our concern is to get u square. So u square equal to 3000 multiplied by g, suppose g is 10 and sine 60 is root 3 by 2. So 2 will get multiplied here and root 3 will come in denominator. So we have got the value of u square. It is not necessary to evaluate u here. Now it says that horizontal range is needed to be 5 kilometer. So let's assume it to be the maximum horizontal range, and if you remember, R max is given by u square by g. So here we have got the value of u square. So u square is 3000 into 20 divided by root 3 into g is 10. Now if we evaluate it, it can't be 5000 in any case. It will be less than 5000. So we can say that it is not possible. Means answer is no. Here question says, by adjusting the angle of projection, can we hope to hit a target 5 kilometer away? No. In no case it is possible. Now here there is one question Prove that maximum horizontal range is 4 times the maximum height attained by the projectile when fired. Here find is given, so this is mistake, so make it fired. So when fired height and inclination so as to have maximum horizontal range. So maximum here horizontal range is given by u square sine 2 theta divided by g. For maximum horizontal range, this term should be 1, means theta should be 45 degree. So it will be u square upon g, which is h max. So theta is 45 degree. Now, in our question, maximum height attained is to be found, and then we have to compare. So maximum height attained. So here horizontal range, we should not write like h, we should write like r. By mistake I have written h. So here r we have got as u square upon g, which is maximum value at theta equal to 45 degree. Now height. So height is given by u square sine square theta divided by 2g. Here theta is given as 45 degree. So we can write u square and sine 45 whole square. So sine 45 1 upon, so this will become 1 upon 2. And here already there is 2g. So this will give u square upon 4g. So we have got h equal to u square upon 4g, and horizontal range is u square upon g. If you compare, you will get 4 times h is equal to horizontal range, r max. I think you have understood. Next question. Show that the height attained by a projectile is triple when fired at 60 degree than when fired at 30 degree, but the horizontal range in each case is same. Let's see how. So height attained by projectile is triple when fired at 60 degree than when fired at 30 degree. So two cases we are going to see. When theta is 60 degree and when theta is 30 degree, we will find the height. Suppose this is h1. So u square sine square theta, sine square 60 degree divided by 2g, which gives u square sine 60 is root 3 by 2. If you square it, 3 by 4. So 3 by 4, here it is 2g. So this is h1 when theta is 60 degree. Now let's find h2 when theta is 30 degree. So u square sine square 30 degree divided by 2g. So it will become u square sine 30 degree is 1 by 2. So square up it will give 1 by 4. So 2g into 4. Now let's compare the two, h1 and h2. So u square, so we can write u square upon 8g outside. So 3 u square upon 8g. So means if we write h1 upon h2, so we will get 3 upon 1. Question says, show that the height attained by a projectile is triple when fired at 60 degree than when fired at 30 degree. But the horizontal range remains in each case same. So horizontal range we are going to decide. But the first part, h1 upon h2 equal to 3 by 1 is proved. Now horizontal range r is given by r equal to u square sine 2 theta upon g. So let's find R1 when theta is 60 degree and R2 when theta equal to 30 degree. This is for 30 degree, this is for 60 degree. So u square sine 2 theta, that is sine 120 degree divided by g, and this will become u square sine 2 theta, that is twice of this, sine 60 degree divided by g. Now see, sine 120 is same as sine 60. If you remember the graph, it's like this. This is 90 degree, this value is 60 degree, and gap of 30. So keep gap of 30, you will reach at 120. Here these two values lie at the same height. This is root 3 by 2. This is also root 3 by 2. So if you observe carefully, so you will get R1 equal to u square by g times root 3 by 2, and R2 equal to u square by g times root 3 by 2. So R1 equal to R2. Second part of the question is also solved. Next question is, a boy stands at 39.2 meters from a building and throws a ball which just passes through a window 19.6 meters above the ground. Calculate the velocity of projection of the ball. Here, let's see the situation, what is happening. Motion is like this. This height is 19.2 meter, sorry, 19.6 meter, and this distance is given as 39.2. So this will also be 39.2. So we can say that h is 19.6 meter and r is 2 times 39.2 means 78.4 meter. We have to find out the velocity. So let's apply the formula. H is given by u square sine 2 theta divided by g, and r is given by, I've written wrong, this is not correct. So here r equal to horizontal range is u square sine 2 theta upon g. In our question, r is 78.4 meter, double of this as we have calculated earlier, and height is given as 19.6 meter, and formula for height is u square sine square theta divided by 2g. Now, if we write r upon h or h upon r, anyone can be written. So suppose we write h upon r. So that is u square sine square theta divided by 2g multiplied by u square sine 2 theta divided by g. And h upon r is 19.6 divided by 78.4. So 1/4. Now let's simplify here. U square, g cancel out. So what is left in numerator? Here sine square theta, here. So 1/4 equals, here sine square theta. So let's write it as sine theta into sine theta divided by, in denominator there is 2 times sine 2 theta can be written as 2 sine theta into cos theta. Now 1 sine theta will cancel out from here and 1 by 4 will cancel out from here, and sine theta upon cos theta will become tan theta. So you can say 1 equal to tan theta or theta equal to 45 degree. So here we have got theta equal to 45 degree. Now further, so theta equal to 45 degree, and we have to calculate what is the velocity. So now we can take anyone, like horizontal range is u square sine 2 theta upon g. So horizontal range is given as 78.4 equal to u square into sine 2 theta. Sine 2 theta means here theta we got 45 degrees, so it will be sine 90, that is 1 divided by g. G we can take as 9.8. Now our concern is to get the value of u, so u square will be equal to 78.4 into 9.8. So if you evaluate, it will come out to be 19.6 under root 2 meter per second square, but we can break it, u square. Now if you write it like 9.8 times, this will become how much? This is in the table of 9.8. Let's see how. So either we pair it, so we will get, if we multiply the same thing we will get, so 78.4, so 19 point, this is 39.2 into 2, so 39.2 into 2. Further if we factorize, so what will it become? Further if you factorize, so it will become 9.8 into 9.8 into 2 into 2 into 2. So here this is u square. Now 9.8, 9.8, 2, 2. These are in pair. So u will be equal to 2 into 9.8 and then 1, 2 will be left. That will be root 2. So this is how you can get, or you can directly multiply and then get the answer. There is no problem. Okay. Here there is another question. R is the horizontal range for angle theta inclination and h is maximum height reached by the projectile. Show that the maximum range is given by r square upon 8h plus 2h. Let's try this question. We have to evaluate it and then it should be equal to r max. So for this, let's see, r is given by u square sine square theta. No, r is given by u square sine 2 theta divided by g. We need r square upon 8h. Let's write h also here, so it will become easier. U square sine square theta divided by 2g. Now we put these values here, so r square, that is u power 4 sine square 2 theta divided by g square, because r square, so this is squared, this is squared, this is also squared, divided by 8 times h. So 8 times h, multiply 8 and then write the value of h. This u square sine square theta divided by 2g. This is first term plus twice of h. So u square sine square theta divided by 2g. Now let's see, something will get cancelled. So u square will get cancelled from here, and 1g will get cancelled from here. This g will get cancelled from here. This 2 will cancel this 4 times. So we will be left with u square sine, here this is sine square 2 theta, and here this is sine square theta. So sine square 2 theta means sine square theta into cos square theta into 4. Why? Sine 2 theta equal to 2 sine theta cos theta. So we can write that value, and before cancelling, here we have 4, keep in mind, don't get confused. And in numerator also we are getting 4. So this is sine square theta into cos square theta into 4 whole divided by, here what is left? Sine square theta is already cancelled, only u square is left. G is cancelled, so 1g is still left, 4g. What about this? Here 2 will cancel out, so u square sine square theta divided by g is left. Twice of h. Now let's see if something is missing here in our question. R square, so sine square theta, here sine square theta, so cos square theta should be left. One sine square theta must get cancelled. Here I have not, so here in denominator there is one sine square theta, so this sine square theta will get cancelled by this sine square theta. 4 will get cancelled by 4, and u square, this was u power 4, so 1 u square got cancelled, so this is u square. Now we are left with u square cos square theta divided by g plus here u square sine square theta divided by g. So u square upon g common, cos square theta plus sine square theta. So it will give u square upon g, which is R max. I think there is slight confusion, so I am just re-explaining the same thing so that confusion may be avoided. So here you have to take R square. So horizontal range R is given by u square sine 2 theta divided by g, and h is given by u square sine square theta divided by 2g. So let's evaluate first term. So if you evaluate first term, so R square, that is u square sine 2 theta upon g whole square multiplied by 8h, 1 upon 8 times h is u square sine square theta divided by 2g. I am doing separate calculation. After that I will add 2h so that thing may remain simple. U square whole square, so u square square, and here sine 2 theta when gets squared, so it will become 2 square, that is 4, then sine square theta cos square theta divided by g times, here this 2 will cancel this 8, so this will become 4, here 4 will be left, u square sine square theta. So 1 u square will cancel out from here, 4 will cancel out from here, sine square theta will cancel out here, so u square upon g times cos square theta will be left. So this is value of R square upon 8h plus 2h. Now, so we put the values here. So we have got R square upon 8h equal to that much. So u square upon g times cos square theta plus 2h, twice of h. H is u square sine square theta divided by 2g. 2 will cancel out. U square upon g cos square theta plus u square g, u square upon g sine square theta. So here u square upon g can be taken inside, outside, and inside cos square theta plus sine square theta will be left, which gives 1. So your answer will be u square upon g. So I think you have understood now. Now, next question is, show about there are two angles of projection for which the horizontal range is same, also so that the sum of maximum heights for these two angles is independent of angle of projection. So if you remember, for same horizontal range, there are two angles of projection. So horizontal range R is given by u square sine 2 theta divided by g. So we write R1 when angle is theta and R2 when angle is 90 minus theta. So R1 equal to u square sine 2 theta divided by g. And now R2 when theta is 90 minus theta, so u square sine 2 90 minus theta divided by g. Now we further evaluate. So sine 180 minus 2 theta, u square sine 180 minus 2 theta divided by g. And sine 180 minus theta is sine theta, so it will become u square sine 2 theta divided by g. So it is same. So R1 equal to R2. So first part is proved. Now consider second part. Second part says, also show that sum of maximum heights for these two angles is independent of angle of projection. See, so when theta, first angle is theta, then say height is h1. So h1 is u square sine square theta divided by 2g. And when angle becomes 90 minus theta, then say height is h2. In that case, here it will become u square sine square 90 minus theta divided by 2g. Sine 90 minus theta is cos theta. So we will get h2 as u square cos square theta divided by 2g. Now we have to find out the sum of h1 and h2. So h1 plus h2 gives, this is sine square theta, that is cos square theta, so u square upon 2g will be common, and then sine square theta plus cos square theta, and that will give 1. So what do we observe? We get u square upon 2g. Here theta is not involved, and in our question the same thing was to be proved, so that the sum of the maximum heights for these two angles is independent of angle of projection. It means theta is not involved. Now here there is another question. At what angle should a body be projected with a velocity of 24 meter per second just to pass over the obstacle 16 meter high at a horizontal distance of 32 meter? Take g equal to 10 meter per second square. Let's see how to solve this question. Okay. Question says, at what angle should a body be projected with velocity of 24 meter per second just to pass over the obstacle 16 meter high at horizontal distance 32 meter? Let's see the situation. So projection is like this. This is, its height is given. Over the obstacle 16 meters. So here this is 16, and its distance from here is given as 32 up to here, and velocity u is given as 24 meter per second. We have to find out what is this angle theta. So you can say this is situation. Suppose at time t we find this situation that x coordinated this, y coordinated this, means this is xy. So for that we write the equation or motion along x-axis and y-axis. So motion along x-axis is x equal to u cos theta into t. X is 32 equal to u is 24 cos theta into t. So this will become 8, 4 times, 3 times, 4 by 3 equal to cos theta into t, or t equal to 4 upon 3 cos theta. We have got the value of t from equation along the x-axis. Now we consider equation along y-axis. So y equal to u sin theta t minus half gt square. We can put the values. Now if we put the values, y is given in our question. So y equal to 16 meter. So 16 equal to u sin theta into t. T is 4 upon, here value of u is also given, that is 24 sin theta into, this is 4 upon 3 minus half g. G we can take 10 into, this will become 16 upon 9 cos square theta. Here this cos theta will be in denominator, 4 upon 3 cos theta. Now let's see what is happening. This is 16 equal to this 496, we can cancel. This is sin theta divided by 3, this will put it as 32, and then tan theta minus, from here this is 580 upon 9, and 1 upon cos square theta can be written as sec square theta. Here this equation can be divided by 16 throughout. So 1 equal to 2 tan theta minus 5 upon 9 sec square theta. Further we can multiply each term by 9. So 9 equal to 18 tan theta minus 5 sec square theta. Now sec theta can be converted into tan theta. So 9 equal to 18 tan theta minus 5 times 1 plus tan square theta. Further we can simplify, 19 equal to 18 tan theta minus 5 tan square theta. We can simplify, this is a quadratic equation in terms of tan theta, and you know how to solve quadratic equation. Suppose you are given ax square plus bx plus c equal to 0, then x equal to minus b plus minus root of b square minus 4ac divided by 2a. So that formula you can apply to get the answer. Let's see next question. Prove that time of flight t and the horizontal range r of a projectile are connected by the equation gt square equal to 2r tan theta. Let's see how. Time of flight, if you remember, t is given by 2u sine theta upon g. Here horizontal range is also to be taken, r equal to u square sine 2 theta upon g. Our concern is to relate the two, g times t square equal to 2r tan theta. So let's write g times t square, g times t square, that is g times t square means 4u square sine square theta divided by g square. So what you have got, 1g gets cancelled. Now gt square we have got at 4u square sine square theta upon g, and they are saying that same result you will obtain when you evaluate 2r tan theta. Let's see 2r tan theta. So 2r tan theta, that is twice of horizontal range, that is u square sine 2 theta upon g times tan theta. Tan theta, let's write it as sine theta upon cos theta, and we simplify twice of u square. Here we write 2 sine theta cos theta times sine theta divided by cos theta. Now, 1 cos theta will cancel out from here. This will become sine square theta, 4, and g is missing, so g should be written here. So 4 times u square sine square theta divided by g. What is this result? gt square is giving 4u square sine square theta upon g, and this one is also giving same thing, 4u square sine square theta upon g. So we have proved that gt square equal to 2r tan theta. So this is all in this video. Later on we will work on other questions. Here you can see this is also one very good question, in which question says, as shown in the adjacent figure, a body is projected with velocity u1 from point A. Velocity is in this direction with angle theta 60 degree, and another body is projected upward. So with velocity u2 from point B, what should be the value of u1 and u2 for both the bodies to collide? So here what will be the condition? What condition you will follow? So I'm just giving hint, then you can solve it. So if you take this body, so height here, time taken for both the body is same. Suppose you consider first the body B, which is moving in this direction vertically here. So for that, h equal to u, velocity is u2, ut minus half gt square. And for another body which is moving at angle 60 degree, whose velocity is u1, height will be same, only then they will meet. So you can say it will be u1 sine 60 degree times t minus half gt square. Now, what do you observe? If you equate these two equations, so hs will cancel out, half gt square will cancel out, t will cancel out, and then you will get the ratio of u1 upon u2. So I think you have understood, or let's complete it. So u2t will be equal to u1 sine 60 degree times t. So t will cancel out, and u2 equal to u1 into root 3 by 2. So whatever you want u1 upon u2. So just invert it. So u1 upon u2 equal to 2 upon root 3. Similarly, in this question says that a projectile can have the same range r for two angles of projection. If t1 and t2 be the time of flights in the two cases, then prove that t1 and t2 equal to 2r upon g. I think you have understood the situation. This is the case when horizontal range is same for the two angles of projection. If you remember, I told you that if body is projected with at angle theta and 90 minus theta, and suppose this is horizontal range 1, this is horizontal range 2, so they are equal. As you know, here time of flight for the two cases, t1 is equal to 2u sine theta 1 upon g, and t2 will be 2u sine, here this theta, not theta 1, 90 minus theta upon g. So t2 will be equal to 2u cos theta upon g. t1 is 2u sin theta upon g, t2 is 2u cos theta upon g. Here they are saying that you have to multiply the two. If you multiply t1 into t2, so what do you get from here? This will become 4u square sin theta cos theta upon g square. Now if you wish, you can convert it into sine 2 theta, because here twice, if you write 2 here and then take 2 inside, so sine 2 sine theta cos theta, that will become sine 2 theta. But let's leave it here and let's solve this portion. 2r upon g, so twice of r, so r is u square sine 2 theta upon g, 2 into r upon g. So here this g is also there, so this will become g, further g. And if you open the bracket, so you will get 2 from here. So this will become 4u square, and this will become sine theta cos theta, because sine 2 theta is 2 sine theta cos theta, and with square that. So 2 sine theta cos theta whole square will give 4 sine square theta cos square theta upon g square. So both results are same. So we have got this result, that t1 into t2 gives 2r upon g. So I think you have understood. In next lecture, we will study circular motion. Thank you, Team Educate.